Okay, I think that might be working. I have no idea. Um, so this is my first experiment in doing live streaming, and let me explain what it is I am trying to do here. Now, I mentioned in an earlier rant that STM32 have this mysterious but very, very cheap processor called STM32F402, which is specifically designed for the Chinese market only. And I find that really bizarre, and I thought I might actually have a go at it. I have also been contemplating doing some PCB development using KiCad or KiCad. I don't know how it's pronounced by most people. I tend personally to use KiCad. No, I don't. I use KiCad, but it's probably called KiCad. I don't know, and it doesn't matter. You know what I'm talking about. Now, if you have watched any of my tutorial videos, you will see that I quite often use a board called STM, one of my own STM32World board. More specifically, I typically use this one, which contains an F405. And if you look at this particular board, it kind of contains an MCU, and then it contains a USB and a power supply and not much else. So I thought, since it's the same pin count, this is a 64 pin MCU, so it's the same number of pins like this one. So the easiest would probably be to create one of my own boards for this particular MCU. So this is what I will be doing in this video. Now, as usual, I have everything I do. I put it in GitHub. That includes PCBs. So I have a folder here which is STM32World hardware, which is my boards, and in here you have this F405 board. And I think the easiest way to go about creating a 402 version of this particular board would be to start with this, because this one is working. So I will probably start by copying this folder and then paste it. Oh, why didn't that work? I hate using, I use command lines normally, so I will copy MCU STM32 F405. I will copy that to MCU STM32 F405, but replace that with a 2. And there you go. Now we have a copy of the original folder. It should be down here somewhere. There it is. And we can start doing some cleanup. We don't need these two folders. We don't need the cache folders. So let's delete all that. What do we have else in here? Let's see. We have this is the PCB file. Let's rename that to 402 PCB. PIL. I don't know what that is. I don't think we need it. This is the project file. We can call that 402 as well. We have the schematic. We can call that 402. Then I have some SVG. This is all ordering files and a caslib and a symlib table. We can delete all those. So we end up with 3 files. We need we have the project, we have the schematic, and we have the PCB. Let's try to open that. So I fire up KiCad, and I open the project, which will be in there and in there. And there you go. It picks up the files. Now, let's start by looking at the schematic editor. That looked okay. Let's look at the PCB editor. That looked okay. So one of the settings I have done here, I do that regularly when I manage, is I create a simple library that is project. Oh, that's interesting. It didn't actually maintain those files, so I think I need to add the where is that? That is in lib, and this was schematic, so it is this one. I need to edit that, add that as a project specific, and we should not have a lib here. So what I will usually do is key prj mod /... because that will point to that schematic library. That should have worked, and I do exactly the same for the footprint libraries. Now this was actually in the original, so I think I must have lib there. Look. So in other words, I have a shared library between all these boards so that I can reuse footprints and schematic symbols. So here we go. Let's try to open this again. Let me try to pick a symbol, see if it actually have. There we go. If I search for STM32World, yes, we have the modules here. We have the base and the connectors and USB and a couple of others. Not many actually. I mostly use standard modules, but let's have a look at. Yeah. Let me talk you through the schematics before we do anything else in this video, and then we'll do the changes for the F402. Let me talk you through what I have in the STM32 F405 board. Now, the schematics is really simple. It starts with the power. Now, it actually, you could say it starts with the USB connector, because the USB connector provides the VBOS, which is and provides the 5 volt, which is kind of wrongly labeled, I admit, because there is a Schottky diode. So if there's 5 volt here, there will only be 4.456 volt or something like that on this side of that. There's also an input protection, and there is some pull down resistors that makes this show up as a device, meaning that a USB-C host will start giving power to this device. Otherwise it won't happen. Now that 5 volt then goes in to the power regulator, which is a standard 3.3 volt LDO linear regulator, low dropout regulator it's called, which basically whenever there's more than say 3.56 volt on this side, it will give you 3.3 volt out of this side. The 10 microfarad capacitors here are selected because that is actually the maximum you are allowed to have according to the USB standard, and that is about it. Then we have some decoupling capacitors intended to be placed at all the power supply pins on the MCU. We also have a little trickery done here. There is a separate decoupling capacitor for the VA and the analog voltage and the V battery. If it is connected, the idea is you have a solder bridge that you can cut, and if you cut that, you can actually battery power the board here only in on the battery pin. It's just a way of making the board more flexible. On here we have the reset and boot 0. We have a button for each of them, so we have a reset button, and we have reset button and boot 0 button. We have a couple of LEDs. One is which is just hooked up to the power, and one which is hooked up to PC13 on the MCU. Then you have the MCU up here. You have power connectors up here. Reset, boot. You have all the ports straight out on the header over here, and you have a crystal, and I choose a 16 megahertz crystal. I will show you later why. And there is a couple of 2.2 microfarad capacitors down here. That is according to the data sheet, because I'm using the internal analog reference, and those two are related to that internal voltage reference. That's it. Okay, I will go on. So let's try to update the PCB from the schematics, and let me talk you through the PCB as well. Let me remove the flood fill there and see how it is. So first of all, let's have a view at the 3D of this. It looks beautiful. One of my favorite features of KiCad or KiCad. So you have the input USB here for power supply. You can also power supply directly on the pin header, obviously. Over here, it goes through that Schottky diode into the regulator. You have the data signals going straight over to the MCU, the D plus and D minus. You have all those decoupling capacitors. You have the crystal over here, and you have the boot and reset pin over here, and the LEDs up here. Now, there is plenty of space on this board. It is not very packed, but that's the nature of things. That is not a concern in this case. Let me talk you briefly through, let's start by going over, start making these changes. So first of all, if I go into page settings, you have, we need to make a change over in schematic setup. You have text variables here. All are good except this one, which should be changed to F402, and the URL will probably also be F402. So let's stick with that. Now let's update the PCB again from the schematic. Update PCB, close. Now let me talk you briefly through how I set up these PCB boards. Now I am where I come from. I'm from Denmark, and Denmark is 110% metric. There's none of that imperial nonsense going on. You might find an old retired carpenter that was working in inches, Danish inches, mind you, not the imperial inches, when he was young, and plumbers might occasionally use some inches as well. I don't know, but electronics is actually one of the few fields that is to a large degree imperial. At least it was when I studied. A lot of the components were imperial. Now these days a lot of components are metric, so you will find a mixture of metric and imperial. So that can be confusing for newcomers. If you choose to do metric only, you get away with it, and then you just have component defined in that metrics. But I tend to mix a bit. Now, I prefer metric. I think in metric, but if you look at a board like this, the header is 100 mil header. That means that if you want to you want to center that on a board, it kind of have to be imperial in order for it to be easy to do. So what I do normally when I work is I design boards. If I can get away with it, I define them imperial. So these boards are 3 inches times 2 inches, and you have the distance between the holes is imperial, and you have this header centered in that. I place components. When I place components, I follow an imperial grid, but when I'm routing, I'm using metric. So in KiCad, one of my favorite features in KiCad, if you go into Preferences and PCB Editor and grids, you actually have some fast grid switching, one which is on the hotkey Alt1 and one which is on Alt2. And as you can see here, I am usually using 25 mils. So this will be the distance where I'm placing components like resistors and capacitors. Whether they're metric or not, I don't care. But I'll follow this 25 mil grid when I'm placing components. Then when I switch to routing or placing labels and stuff like that, I will switch to this grid, which is the finest grid you can make. So essentially everything I want aligned, I align to this imperial grid, but everything else I do metric. So let's try to zoom in and show how that is working. So if I press Alt, what did I do there? Alt1. There you see. So you can see the grid here is the 25 mil, and you can see that lines up with the pins on this. It lines up with the holes, the mounting holes. It lines up with the edge of the board, and it lines up with everything else. But routing might be a little too you might want to do it a bit closer. You can see these are actually closer. So I do all the routing. I'll switch to this grid, which is an extremely fine grid. You can almost, I mean, it won't even show it. Yeah, you're probably down there. So it's a very, very fine grid. You can, of course, switch to others if you like, but I find that I rarely actually bother to do that. I just do these 2 grids, and that works fine. So what do we need to do here? Well, in order for this to become a STM32F402 board, well, we need to change the MCU. So let's start by looking at what we actually have here. Hang on. There. The package is a standard package, and the value is, so it is actually a standard component I'm using. I don't think RTX. So let's see if we actually have that MCU in the standard libraries, otherwise we'll have to create one. STM32F, we want to use the 502 RTR. So what are we talking about here? Was it RC? Oh, I forgot already. RGT. So we go in here and F401 RT. So we actually do have that MCU. Is it designed in the same manner? It is kind of a drop-in replacement, which is pretty much what we expected, with one little difference. So let's start by putting this here. That was actually, where is it? It's called U2. So let's just delete that and move this up. and move this into the same location and see if we can make it all. I don't have a VDDA. That's actually a little bit, doesn't align perfectly. So let's not do that yet. Let's move the stuff out of the way that needs to be moved out of the way. So I think these were in the way, so let's move that up for now. And presumably these would have been out of the way, so let's move that out of the way. And let's move this one. See if we can get it aligned reasonably. That's a little bit. There's actually quite a lot of pins that will not really work here. Oh well, let's deal with that as it comes along. So first of all, this stuff down here needs to be moved out of the way. There, and this is PC 15, so can we can. So why don't we do it like this? These, starting with PC 0. No. That will do. We move those. Are they all lined up? They are lined up. So that is a good start. This one we have a PD2. We can move that. Right. Move that down there. Move that one down there. And we have the crystal. It's, how do we do that easy? It's probably easiest if we do like that and drag. Okay. This down there. And I don't know why that one. It's probably easier to pull a new one. There. That is all that. Recap. Let's get the rest of the pins. So PB0 down to PB. What goes wrong here? 9, 10, MCU doesn't have an 11. So that's interesting. Wait. 12. We can move that one up there. 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 And delete that one. 10, 12, 13. Do we okay, we can deal with that later. Up here we have PA 0 down to PA 15. That's all good. Up here we have a V battery which we can reuse. There. We have the supply here which we can reuse. I have to look in the datasheet why there is no VA or whether that's needed. And down here we can put our ground back there. Also, I like to have that one. Actually, why don't we put that in the center? It looks better. There, and we can move our designator up where it was before, probably. There's good. And I think I want to rename that to U2 because that's what it was called before. So let's look at the, it is using the QFP. It's probably all good. Oh, that is is actually a pretty good start. Let's start looking at the datasheet, and I'm going to use the one that the KiCad library actually refers to. So let's go over in my browser and look at the datasheet and see if we can get any explanation for the oddities that I found, which is why is there no V analog. Let's search for it actually. DDA. Power supply and reference decoupling. We ref not connected to VDDA, but we have a VDDA. So where is that actually? Is simple. I mean, it is entirely possible. VDDA is pin, where are we, 64 here. VDDA is pin 13. Pin 13, remember that. So this is actually the one that was called VDDA in the earlier. So what I will do is I'll move this one, rotate it around, and simply put it there. There. Let's connect that up to that one, and let's nuke that. So this is there anything else odd? Well, we don't need two of these, so we can kill off this stuff. Kill off this one, because we only need one of them. Well, let's move that up to about there. So that's about it. So let's try tools, update PCB from schematics. Update PCB. Okay, so it, as expected, let me switch to my there. View 3D viewer. It still keeps the old one. That's I don't know why it does that occasionally, but let's nuke that, and let's move this. See if we can get this moved into location. I think that is about where the other one was. Now there is probably going to be a ton of errors around this, and something we need to remove, and something we need to. So let's do. Let's start with view. No, let's start with design rule checker and see what happens. How bad it is. Very bad. It made KiCad crash. That I have not seen before. So there was something very, very, very confusing. At what point did it crash? It crashed completely. It didn't save anything. How do I deal with this? Did it forget all my changes in here too? Then I'll be potentially appeared last time. Not saved. Do you wish to restore the last saved edit you make? Yeah, let's do that. Okay, almost okay. Didn't remember that. It didn't remember that. So let's delete this stuff down here. Let's move that stuff over there. I think that was all. Let's save it this time. Before it crashed again, let's the only change that is made in the PCB is actually the MCU. So how about we go in here and we actually delete the old MCU, and then we save that, and we go back to the schematics, and this is yeah, this should be okay. So let's tools, update the PCB from this one. Nope. Yes. Let's do it. Update the PCB. Close. There is our, we switch to the proper grid. We can use these, wait, I'm not using the proper anchor point. Easiest way to align this is actually I put a wire in each corner, this wire and this wire down here. So if I align those wires, then it will be aligned correctly. So there, let's try to save this before I crash it again, and inspect design rule checker. Let's try to run this again, see if it crashes one more time. Actually, let me, hang on. Okay, there's a bunch of errors. There is items shortening to nets. That is related to our, so let's remove this trace and let's remove this trace. Let's see if we can just by removing chases inspect design rule checker. Let's get that up again and run it one more time. We have another one. Where is that? Let's move this out of the way. What? Let's remove that on the DRC again. Remove that for now. I just want to make sure I don't have any old leftover connections and get them out of the way. Okay. Okay, now I know where we're at. So actually, let me start by fixing this little problem because I've seen this before. So this component, okay, if we go back to our schematics and look at this component, it's using an STM32 USB receptacle. So let's look at that USB receptacle in the library in my STM32World library. So we go over here and fire up the footprint editor. There, and we find the STM32World footprint. That's weird. Why it doesn't show up if you search. Anyway, it's this one we are talking about, and let's look at the footprint properties of that one. And it is actually defined as a true hole because it's got those mounting holes in the corners. So let's make sure that is up to date, and then we go back into the PCB editor. And what is happening here? That's a little bit weird. Why does it have two? So let's tools. I think we need to update the footprints from the library, update all footprints, and let's see what happens. It's still having two. What is happening out here? Okay, there's a little oddity there. Let's try to run the design rule checker one more time. That I have not seen before. Okay. Expected true hole. Actual SMD. Why? Is it 2 or something like that? Is view 3D viewer? No. But there's no holes for it. Are there anybody on this live? There's actually people on this live stream. That's quite impressive. I don't know why you're here, but well, I appreciate it. Nobody said anything. I can see the chat over here. Anyway, so I think I know what is happening here. Hang on, let's see if again. Getting better. So what is happening here is the edge cut. I actually defined the edge cut in the footprint, and I defined the edge cut obviously on the original board, but I didn't update from the footprint library from that one, and that is why we ended up. So now we are back with that one problem here with this particular footprint. So let's try to wait. can we update the footprint? Update selected footprint, but let's try to update all. Probably fixed it. There we go. We are down to no of these violations. So the violations we have right now as warnings, they are all, oh, there's some unconnected ends. We will deal with those. But there is no of these violations. What, I don't know what this one is doing out here. Irritates me. So basically we have some silk screen that is cutting other silk screen or the board edge. Let's have a look at the 3D viewer just to verify everything is still looking. That one looks properly placed. That looks aligned. Are these okay, I noticed an error here. This is a new board, so we should go into the board setup, text variables, and this is indeed revision A we're working on. What is happening here actually? PB11, that was the one we were taking out, right? So essentially, if we go back to the schematics, am I right? PB11 didn't exist on this MCU, so if we go out here, over here, and find PB11, where is that? PB10, PB11, this one does not exist, and should be capped off with that. Duck. There we go. So PB11 is no longer connected to the header. So if we update the PCB from this, now I cannot remember XX how I do the silk screen on these boards. Should I? I'll leave it. It's just not connected on this board because PB11 doesn't exist. It's okay. It could be connected on another board. Let me also, I don't like that fab stuff, so I usually remove the fab view. It just confuses things. So yeah, I wonder what this warning up here is. Oh, okay. Yeah, I get it. It's a warning that there shouldn't actually, there's no need actually for a wire there. I just kind of like it. So where does it go to? I'll actually get rid of that. So no, I cannot because I got that line there. I got that trace there. My power trace is running through this, creating. Yeah, it is best that way. Track. I live with it. I live with that warning. Boot 0 here is unconnected. Fine. Remove it. What else do we have? let's get rid of all these warnings. Wait. Tools, inspect, design rule checker. Track has an unconnected end. Huh? Why would that have an unconnected end? I think I need to do a, where is it? Is it under tools, or they move that around occasionally? Clean up tracks and wires. Let's clean up all unused redundant wires and there, update PCB. Let's see if that creates disaster. Let's rerun the DRC. Actually got less. I live with this one and I exclude this violation. I exclude that violation. I exclude those clip by board sets. I exclude all of them. Well, I can make that look better. Actually, let me fix that. So I switch to my metric and I just move that one up a little bit. There. Actually, I got it. No, it's fine. Let's. Where's my DRC? Tools, inspect, design rule checker, run DRC. Still screen overlap. What is that? I live with it. Exclude. Exclude. It doesn't matter. So now we're down to one unconnected item, which is where? Okay. So our C14 up here is actually the one we have down here as C12. Remember, I flipped those around. So let's put this one there and let's nuke this one and let's move this one over there. Let's switch to, I don't like that, and let's switch to 9mm trace, which is what I usually use, and then let's hook that up. What is this one? Suppose that's actually a ground pin. We should probably be brutal and put one more up here and probably one more down there to make sure that this is properly connected. Let's look at the float there. It is beautifully connected. So no problem. There's a ground pin over here that is surrounded by ground. No, I don't know why it is. 3D viewer. All good. Still, let's almost impossible. I don't understand why it is doing these. No. Anyway, I don't know how long this has been running. It's been fucking. This is incredible. I don't know why you guys, if any of you have actually been around. Oh, there's actually somebody who wrote. Sorry, didn't see this. It is the first time I've been streaming, and well, I don't know. It just seemed the only way I could actually do PCB design would be by streaming it like this, and then maybe cutting it into a better video later. I don't know if I'm going to get around to that, but anyway, it's also philosophically actually a little bit interesting to do this. I must admit, I work alone quite a lot, and I occasionally catch myself talking to myself, which is also always a little bit embarrassing, isn't it? So in this case, I'm allowed to talk to myself, and that is actually really quite interesting. So there you go. Am I going to do this again? Yeah, but I'm probably going to finish this board. I don't know exactly when, but I'll leave the live streams up. So, well, that's about it. Now, I am going to take a break now because I actually haven't had my breakfast yet, so that is about it. I don't know. End stream. I got a button here. So guys, I am going to end this now. Please comment. I'm sure there will be a place to comment whether you want more of this. I should probably schedule it in the future. Otherwise, I can't really expect anybody to be here. But well, there you go. I'm going to end this. I need my breakfast. Wait, sorry, there was a amazing and valuable thing. Okay. Let's get into but need this. Yeah, I'm actually. I'll comment on that. There's a Julius Caesar. I bet it wasn't that one. Who writes that this is an amazing, valuable thing you're doing. People such as myself who wants to get into embedded need this. Actually, and I am probably going to make some video series about that. What you really need is some electronics 101 before you start with PCB design. And I am probably going to do some videos with Electronic 101. One of the things I have done, I can show that briefly here. I actually found that somebody wrote an electronic emulator, simulator in JavaScript, and I put it on my STM Circuit.js, it's called. So if you go to stm32world.com/circuitjs/circuitjs.html, you actually have a quite capable and quite good electronic circuit emulator. And I was actually thinking about using that circuit emulator to to run a few courses, but I still need to figure out the format. Meanwhile, I'm going to stick with my STM32 tutorial videos and an occasional rant, and well, we'll see if I ever get finished with this. One of the problems with KiCad PCB development video, these are going to be really long. And I hate editing videos, so I don't really know how to get these videos edited into something that can be used. Could I post the link to what? I'm sorry, verbal thing. The link to the PCB, if that is what he means, it is on the GitHub, same as everything else. If you go to GitHub STM32World on GitHub and look at the available repositories. The emulator. Okay, yes, where can I can post it there? Yes, sure. Hang on a second. There. Should work for everybody. It doesn't save anything on the server. Did that work? Yes, it did. So yeah, if you want to play around with that, it is actually quite a capable emulator. I was positively surprised when I discovered it. It's good to play around with. So yeah, look at that. And I mean, the point I was trying to make is you need to understand just basic electronic. It doesn't have to be, you don't have to understand RF or whatever to start playing around with this, but you need to understand the basic. You need to understand current voltages, voltage dividers, basic functionality of regulators, MOSFETs, transistors, the basic how this works in the digital world. You need to understand that. So there should probably be a Electronics 101 series coming up. Anyway, as I said, I need my breakfast. So I am going to end this chat now. For the 2 or 3 people that actually discovered this, it's been 27 views. I'm blown away by that. But anyway, most left. So it was probably fairly boring. So there you go. Enjoy the rest of your day, and I'm probably going to do this again at some point, maybe later my afternoon. So in 4 or 5 hours, I might actually continue this stream a little bit. But till then, bye bye. Have a wonderful rest of the day.